Chemistry, we're on to lesson 3 in the reactions unit, and it deals with the first step in using chemical equations, and that's balancing the equations. An equation must be balanced before it can be used in chemistry. The first method we're going to talk about is called the box method, and this is a good method for beginners. So what balancing equations means is, here we have a number of elements in these compounds. We have vanadium, oxygen, hydrogen, and chlorine. However many atoms of each of those we have before the reaction, we must have that same number after the reaction. So whatever number of vanadium atoms there are in the reactants over on the left, there must be that same number over in the products on the right. The same is true for oxygen. You can't create or destroy atoms in a chemical reaction. All you're doing is rearranging them and recombining them. But you must end up with the same number of each of the atoms of each element before and after the reaction. So let's go ahead and see how the box method works. The first thing we do is we draw a box underneath each of the compounds, and it simply, you write the letter of that element that's in that compound as many times as the subscript tells you. So for vanadium, we write 2 V's. For oxygen, we write 5 O's. For hydrogen and hydrochloric acid, we write 1 H and 1 Cl. Over on the right, we have 1 V, 1 O, and 3 Cls. And then finally for water, we have 2 H and 1 O. So you'll notice that on the left side of the arrow, there are 2 V's over on the left side, but there's only 1 V on the right side. So that can't possibly be a valid chemical equation that we can use as such, because somehow one of the V's would have had to have disappeared, and that can't happen. So what we need to do is make the number of each of the elements the same on both sides. So what you do is you pick an element to start with that you're going to balance first. And you pretty much have your choice of which element you want to start with. We could start with V, O, H, or Cl. There's a couple of rules, though, of what you don't want to start with. You don't want to start with any pure elements. So if you have oxygen O2 or hydrogen H2 all by itself, you don't want to start with that. You want to save that for the end. And why that is, you'll become familiar with as we move on. The other thing you want to avoid is any element that you see more than once on the same side of the arrow. So if you look over on the right side, the product side, you see oxygen is in VOCl3, and you also see oxygen is in water. So it's in 2 different locations on the right side of the arrow. That means it's going to be complicated to balance that, so you want to save that for the end. So that still gives you the choice of either V, H, or Cl. So in this example, we're going to start balancing V. We see that we have 2 V's on the left side of the arrow and 1 V on the right side. So what we want to do is add a V over on the right side. But you can't simply add a V. You have to add that entire compound, VOCl3. So what we're going to do is add a second box of the VO with 3 Cl's in it, like this. And there we go. So now the V's are in balance. You have 2 V's on the left side of the arrow and 2 V's on the right side of the arrow. Now you can choose between either hydrogen or chlorine to balance, Cl. And in this example, I'm going to do the chlorines first. So you'll notice on the left side of the arrow, we have only 1 chlorine. On the right side, we now have 6 chlorines. You see Cl 6 different times. So in order to make those balance, we have to add enough boxes to the left side so that we have 6 chlorines on the left. So here we go. There's a second chlorine, a third, fourth, fifth, and sixth. So now we have 6 chlorines on the left side of the arrow, 6 chlorines on the right side. Now sometime when you go to balance that second element, you might throw the first element that you balanced out of balance. And that might seem kind of frustrating, but that's just the way it goes sometimes. You may have to go back and balance that element a second time, but here we didn't have that. Adding the chlorines did not affect the V's. So now we have 2 V's on the left, 2 V's on the right, and now we have 6 chlorines on the left and 6 chlorines on the right. So now let's look at hydrogen. So if we look at it, we have 6 hydrogen on the left side of the arrow and 2 over on the right side of the arrow. So think about it. What are you going to do? You're going to add another box and another box. So now we have 6 hydrogen on the left and 6 hydrogen on the right. And so everything is in balance except we haven't checked the oxygen yet. So we have 2V on the left, 2V on the right, 6Cl on the left, 6Cl on the right, and 6H on the left, 6H on the right. And it just so happens that, since we saved the oxygen to the very end, it looks like we now have 5 oxygen on the left. We always did. We started with that. But now we also have 5 oxygen over on the right. So by saving the hardest one to balance until last, it kind of fell into place, and that often will happen. So the way you write the final balanced equation is you count how many boxes are underneath each compound, and that becomes the coefficient in front of that compound. So down at the bottom is what the balanced equation would look like. You have 1V2O5 because there's one box. You have 6 boxes below HCl, so there's 6 HCl. You have 2 boxes below VOCl3, so there's 2 of those, and 3 water molecules. And that is your final balanced equation. You have the same number of atoms of each type on the left side of the equation as on the right side of the equation. A second method is the standard way to balance chemical equations. This is the way you ultimately want to learn to balance the equations, but the box method is perfectly fine. It just takes up a lot of space. So what you do on this one is you list each of the individual elements below the arrow, right in the middle below the arrow. So we have a V, O, H, and a Cl. Now you simply count the number of atoms of each element on each side. So with V, we have 2 on the left, and we have 1 on the right. For oxygen, we have 5 on the left, and now be careful, there's 2 in the there's 1 in the VOCl3, and there's 1 in the water. So that's going to give you 2 on the right. For hydrogen, we have 1 on the left, 2 on the right, and for chlorine, we have 1 on the left and 3 on the right. So nothing is in balance. We're going to follow the same pattern we did on the last one, but you're going to see how you cancel the numbers and how you work through the numbers. This one maybe is a little trickier, but you'll get used to it, and you can do it in a lot less space than the box method. Okay, so again, we're going to start with V. So what we're going to do is put a coefficient up above. The reason to put it up above is it might not be the final coefficient that you want to write in front of VOCl3. So you put it up above, and now you see how that affects the rest of the equation. So what that does is you now have 2 V's over on the right side of the arrow, so we're going to cross out the 1 and put a 2 there. But remember, that coefficient doesn't just affect the V. It affects the O, and it affects the Cl3 as well. So we now have, on the right side, 2 oxygens in the VOCl3, but we also have that one in the water. So we now have 3 oxygens on the right side of the arrow. Be sure you understand that. There's 2 in the VOCl3 because of that coefficient, and you still have the 1 over in the water molecule, so that's a total of 3 oxygen. So we cross out the 2 and we put a 3 there. Finally, the Cl3, you now multiply that by 2, so now you have 6 chlorides, or 6 chlorines on the right side. So we're going to take that 3 down there, we're going to cross it and put a 6 there. Okay, so now as we look at that, we have the V's in balance, nothing else is in balance yet. So now we're going to go to the Cl's. So we have 6 Cl's on the right side. 2 times 3 is 6. So now we're going to put 6 over on the left side. So we put a coefficient of 6 up above HCl. So that now gives us 6 Cl's on the left side. So the Cl's are now in balance. And also the hydrogen. You now have 6 hydrogens. So we're going to go ahead and cross the 1 off the hydrogen and put a 6 there. And we're going to cross the 1 off the Cl and put a 6 there. So now you can see the chlorines are in balance and the vanadium, the V's, are in balance. Okay, now what? Well, let's look at the hydrogen. We have 6 hydrogen on the left side of the arrow, and we have 2 hydrogen over on the right side. So what we're going to do is add a coefficient of 3 to the water molecule. So now you have 3 times 2 is 6 hydrogen on the right. So we'll change that on our tally down below. The 2 becomes a 6. Now everything is in balance except for the oxygen. However, it is in balance. We have 2 oxygen in the VOCl3, and we have 3 oxygen in the water molecule. That's 2 plus 3 is 5, so that changes the oxygen to 5. Now you can see that every element is in balance. You have the same number of atoms of each element on the left side as on the right side. So now we can go ahead and write those coefficients, rewrite that equation. If you were doing this on paper, you would just erase those coefficients up above and just stick them actually in front of the compound. So we have 1V2O5. Again, I do want you to write coefficients of 1. We have 6HCl, 2VOCl3, and 3H2O. And that takes care of our lesson on balancing. If you do about 10 of these, you'll be great at it. And it's the first step in working with chemical reactions. You can only work with a balanced chemical equation, that is. And so it's a skill you need to learn, and you'll get it in a short time. Okay, that takes care of this lesson. And we'll move on to working with chemical equations and how they help us to determine how much of the reactants we need and how much of the products that we are going to end up at the end.